if it is later. Before that, I will just introduce you to some important concepts regarding big data analytics, and which I wanted to show you. Okay, as I told you in the morning session, that I will be explaining you some real-time applications and research applications of big data analytics, along with one of the patents, and I will be explaining you some open research problems about big data analytics as well. So this is basically one of the book chapter. It was published as a book chapter, and later we altered that particular idea to publish it as a research paper as well. So I'll just try to explain you the concept behind this. I told you earlier as well that it is very important to combine two or three areas of research to produce quality research. I hope that my screen is shown to all of you. Is it visible to all, ma'am?
Yes, sir. Yes, sir.
Okay, fine. Thank you. So, uh, nature-inspired algorithms in big data. In this particular concept, or in this particular paper or book chapter, I will just explain you that how I managed to combine big data analytics with wireless and IoT. See, as we can see here in this figure number one. Let me just zoom it a bit. Yeah, as we can see in this figure number one, we have individual sensor nodes specified by our, green shapes, and then our blue shapes specifies our cluster heads, and they all transmit data to this base station here. To this base station here, this is the principal structure of a wireless sensor network. Now, what if no, a particular cluster head breaks down in the sense all these green dots will collect information, and all these green dots will have a limited storage ability, means they cannot store a huge amount of data, which is why they periodically send the information aggregated by them to these cluster heads, which are specified by blue dots. Okay, and then this all information from one blue dot to another another blue dot to another blue dot will be transmitted to
Sir, your voice is not audible, sir.
Yes, ma'am. Is my screen visible now?
Yes, sir. Now it is visible and audible, sir.
Okay. Actually, I'm sorry, dear faculty. My internet was lost, which is why I got uh, disconnected. So
Okay.
we'll just go ahead with what I was explaining. I don't know at which point my internet was lost, so I will just explain it to you again. Uh,
Okay, sir.
these these are my green colored sensor nodes. Okay, these nodes are used to collect information. These information, this particular information can be aggregated from anywhere. Like sensors could be placed in your institute or in your university, in a hospital, or at a traffic light to see the speed of the vehicles or to see the number plates of the vehicles, or these sensors can be placed in a hostile area as well, like a forest or a mountain. So what I want to say, dear faculties, is that these sensors forms the integral part of today's 5G and IoT, which makes their use crucial in present age. So how these sensors are related to our big data analytics. So I will just come to that point later. I'd like to just explain you here. These sensors, green color sensors, aggregate data from their surroundings, and they send their respective information to these blue dots, which are called cluster heads. Okay. Now here we have shown only five cluster heads, but in present day real time scenario, we may have 5,000 of them. We may have five lakhs of them. So a IoT structure is huge in present date, and we have many sensors, million of sensors, and million of cluster heads. Now, how their operation works is that these green dots, they sense the information. After sensing the information, they send the information to the cluster head. Then one cluster head sends the information to its next cluster head. In the same way, uh, this particular cluster head will transmit the information to its next cluster head, and they all send the information to the cluster head which is located closest to the base station, that is this black one. Okay, so in this case, the operation of this black cluster head becomes very crucial because it contains all the information or sensed d- da- data by all the cluster heads which are located behind this black cluster head. Now, what happens if the storage ability of this black cluster head is full? In that case, it will stop receiving the information. It will not have any storage abilities, and all the data that is being sensed by the cluster head behind this black cluster head will be lost. So this makes the storage ability of this particular cluster heads very crucial. And if this cluster head goes down, then my entire structure is useless. Okay, so this is an open research problem, that how can I optimally use the storage space of each cluster heads in a IoT or wireless sensor structure. They all are allotted equal amount of storage space, and how can I optimally use that storage space to enhance the performance of my structure. And here we will use AI algorithms and big data algorithms as well. So the bottom line here is that we see huge amount of information and we see huge amount of data being produced, but the basic source of this information is the sensors. So we just cannot separate these two areas, and if we can combine these two areas together, then it will form a fantastic area of research, and it is indeed an open area of research in the present age as well. So I'll just explain you what I have performed in this article. What I have done, I have basically proved or shown that these sensor nodes, means the green color dots, they emigrate a huge amount of data, and in order to process that data, what I will need, just a second. Okay, I will just explain you step by step. Uh, this is biogeography based optimization based wireless sensor networks. BBO is basically my artificial intelligence algorithm. It is used to optimize the performance of big data tools or big data algorithms in extracting useful information from a huge amount of data. Then I used another artificial intelligence algorithm, that is gray wolf optimization. Gray wolf optimization is an improved version of VBO. It was introduced in year 2015. All these algorithms, you can use any of these algorithms in your future research as well. You will find many research articles on these algorithms, which I'm speaking on IEEE Explore as well. That is BBO, biogeography based optimization. Then we have gray wolf optimization, that is GWO. Then we proposed an extended BBO algorithm, which is an enhanced version of BBO. That is, the BBO was improved, and we used extended BBO as well to improve the data extraction process of big data. Then after that, we also implemented this by using particle swarm optimization. PSO is also another meta-heuristic or artificial intelligence based algorithm which can be used to improve the performance of big data tools. And it was introduced in 1997. Although you may think that it is an old algorithm, but it is still very much useful in present age due to its better optimization performance. Uh, After that, I just wrote or proved that wireless sensor network and big data analytics are closely connected to each other. Let me just read this out for you. Above, we saw the utility of nature-inspired techniques in wireless sensor networks. BBO, EBBO, and PSO are successfully used to achieve energy-efficient wireless sensors. The amount of data emerging from the wireless sensor network is huge, which encourage the use of big data tools in wireless sensor structures as well. A wireless sensor scenario can operate efficiently if it is merged with big data algorithms. In the next section, we study how nature-inspired techniques can play a crucial role in optimizing the performance of big data tools. Big data and nature-inspired algorithms. It is the introduction of big data that we have already studied. Then in section 4.2, velocity in wireless sensors is very uh, crucial, especially for real-time applications like room surveillance, healthcare systems. Sense data should be read and processed with velocity in order to respond properly in real-time applications. Velocity parameter of big data is a feature of wireless sensors as well. Then we come to second main aspect of big data, that is volume. Working of wireless sensor networks involves large volumes of data. There is huge amount of information emerging from the sensors in the form of sense data. This satisfies the big data parameter of volume to wireless sensor structure as well. Then we have variety. There are many types of sensors sending a variety of information. These sense data of light sensor will be separate from the data of a temperature sensor or ultrasonic sensor or flex sensor. Different sensor deployed in various areas for various applications also generate a large variety of data which map the big data parameter of variety to wireless sensor structure. So what it says here that since we have various kind of sensors associated with us like light sensors, velocity sensors, proximity sensors, flex sensors, all these sensors will produce a large variety of data which you know joins the variety parameter of big data to IoT or wireless sensors. Then we come to volume part. As we can see that our sensors produce majority of the data that is being produced in the present age. So it connects the volume parameter of big data to our wireless sensors, and then we have our velocity. Here we have shown that in the real-time applications, the data emerging from various sensors, it has to be properly managed and used, and it should be processed in less time so that it could be useful in real-time applications as well. So here we have shown that all three parameters of big data are related to our IoT or wireless sensors. It is shown in figure 1 as well. As we can see here, uh, then we move to our 4.3 part, that is role of nature inspired algorithms and extension required for the present work. So basically, dear faculties, what I have shown here, let me read this stanza as well. It will be useful for you. Big data algorithms involve mining of huge amount of data at a rapid speed, that is large data sets to be processed within a limited amount of time. This is very similar to what wireless sensors data requires. In a wireless sensor structure, we need to find appropriate set of data at a fast speed out of a huge data set. For this requirement of wireless sensors, big data algorithms can be very much useful. This analytic problem can be referred to as the optimization problem. The term optimization refers to finding the best possible solution in a limited amount of time out of numerous number of available solutions. Okay, this is the basic definition of what we mean by the term optimization in our in our article. This problem can be solved as an optimization problem using nature-inspired algorithms like BBO that I explained about, that is biogeography-based optimization, and extended BBO. Since these algorithms have already shown very fine results in wireless sensor structures, although big data suffers from the course of uh, dimensionality problem, that is the performance of mining the data degrade as the size of the dataset increases. This problem can be solved as an optimization problem using nature-inspired algorithms. The big data emerging from the sensors deployed in healthcare systems, traffic monitoring changes rapidly along with time. Swarm intelligence and other nature inspired algorithms can be successfully used in handling dynamic changes in the big data. In swarm intelligence and other nature inspired algorithms, measures can be taken so that they solve the dynamic problems satisfactorily. Hence, these nature inspired algorithms can be used to cater for dynamic requirements of big data. I'll share this file with ma'am so that you can also see this. So, this particular paper shows that how we can connect wireless sensors to our big data analytics, and you can actually prepare a good research paper combining these two areas of research. uh, Large amount of data will be produced from wireless sensor structure used in areas like surveillance of large space, security measures, emergency engineering surveys, etc. Big data plays an important role here. It is used to convert this raw d- data into useful information as fast as possible. Nature inspired algorithms can prove to be very effective in the process of obtaining useful information from such raw data sets. So, from here, we can say that wireless sensors and big data are closely connected since the large amount of data emerging from sensors can only be handled using big data tools. Nature inspired algorithms like BBO and extended BBO are widely implemented and have proved their worth in wireless sensor structure around the globe. These techniques can be used in big data. Searching for a appropriate data in limited amount of time can be framed as an optimization problem, which can be effectively solved by nature-inspired algorithms. Furthermore, PSO, that is particle sum optimization, is implemented in big data. Successful implementation of PSO not only paves the path for nature-inspired algorithms in big data domain, but also outline the need for better algorithms to be implemented in big data in future. So from this particular talk or from this particular discussion, we can safely say that here there are three basic factors. One is our big data, two is our wireless sensor structure or IoT, we can say, and another one is our meta-heuristic or artificial intelligence algorithms. Now, these three are three separate areas of research, and we can combine any two, like combine big data with IoT or combine big data with meta-heuristic algorithms or artificial intelligence algorithm. So from this particular article, I just wanted to show you that how we can merge various areas into one and produce some very fine quality research. Then we move to our next topic. It is one of the patent. Uh, Let me just show you. Yeah, this is I wanted to show you. Uh, yeah, okay. This is one of my patents that I filed about a year ago, and it have received early acceptance uh, just about a month back. So I will just explain you that what I have done in this patent and how big data algorithms are used in this particular work. Okay, so what this particular work do? This is a Boeing 737 that is a passenger aircraft that we have used. And Boeing 737 is being simulated in MATLAB. Now, since a particular aircraft flies from point A to point B, let's say from India to England, uh, during its flight, it produces a huge amount of data. And let me just show its code to you. Okay, see here. What I have, you know, performed here. This is the simulation of a particular aircraft. It can be anything like Boeing 737. And I have made this into a GUI, that is graphical user interface. I can change the coordinates of this particular aeroplane by clicking this particular graphical user interface, like here, and here. As you can see that as I change the coordinates of this particular aircraft, at the bottom you can see its position is being displayed, its direction is being shown, and this position and direction are stored in tables, and all this position and direction record is being stored. So since the plane flies from point A to point B, say from India to England, so along its path, it produces a huge amount of data to be stored. For example, its position alters, its coordinate alters, its flight speed alters, its flight direction alters. All these coordinates are stored, and a particular database is formed. Now, what I want to do here is I want to implement this Boeing 737 into a humanless drone. Okay, into a humanless drone. Now, what that drone will do, that will fly on its own without the intervention of any human or any PC or any computer. Presently, USA have the Predator drones that are humanless, but they are still controlled by the computers located in USA. But what I want to do, I want to make a drone which is computerless as well as humanless. So for that, what I need to do, I need to simulate the path, flight, speed, direction, and all these important and crucial parameters of the flight of a plane or a humanless drone, store them in a database, use big data analytics and artificial intelligence. That is a combination of big data analytics tools and artificial intelligence to predict the future flight parameters of a particular plane or a particular drone. Okay, I hope you are understanding what I'm trying to say. If I have a drone which is operated by humans, and if that drone flies 500 flights from point A to point B, what I will do, I will store the data connected to that 500 flights in a particular database, and after storing the data, I will have a huge database. Now, my task will be to apply a combination of AI predictive algorithms as well as big data analytics tools to predict the optimum flight path of that particular drone. If we are able to do that, we will remove the need of a human or any PC or a computer operating the plane or a drone from Earth. Okay, so this is what we aim to do, and this is exactly what I performed in this particular patent. That I just store the information in database, and I just predicted its optimum path and its optimum flight parameters. Let me just show you something here. Let me just show you how I performed this. This is hardware and description here. I have specified the steps here. I will share this file as well with ma'am, so you can see it for your reference. Then I have, explained the implementation part here, that how it is being implemented. The flight autopilot mode works in a similar way, but it follows a pre-specified path and has no mechanism to calculate optimum velocity that minimizes the fuel consumption of a flying object. Moreover, the autopilot mode is costly and used only for the flights. There is no autopilot mode in light aircrafts like UAVs or drones. Most of the UAVs and uh, drones are always operated by a combination of computers. The proposed method is not only cost effective but is also applicable to all the pilotless vehicles, light or heavy. Furthermore, unlike an autopilot mode of an aeroplane, the proposed uh, chip does not use a combination of computers. Instead, it uses artificial intelligence and is able to find out the intelligent coordinates and velocity on its own based on the training set. Training set is prepared by using predictive analysis, which is a big data analytics tool that I explained you in the morning. That if we have the information or the data of a particular organization for last 5 to 8 years, then I can predict its performance for upcoming 5 to 8 years as well. So this is a kind of a predictive analysis. So we use that particular area in this research, and I just implemented it. And on the basis of artificial intelligence, I have used PSO here, that is particle swarm optimization, to optimize the parameters. These are the flight screenshot that we obtained. These are the positions, directions, rotation, rotation in far view around x-axis, rotation around x-axis in far view, and these are some of the outputs that we obtained. Lifetime of a UAV was increased. So, this particular area or this particular research uh, was used as a combination of AI algorithms, big data analytics, as well as some uh, flight path parameters as well. So it combined three research areas into one. So I hope that this concept will be useful to you. Okay, so another thing that I want to explain you here, just a second. Okay, I'm unable to find that PPT. I will just explain you later. So I hope this particular talk or this particular section will be useful to you. And if you face any problems in working in these areas or working in this research, you can contact me anytime in future as well. My email ID is with ma'am. So let's go ahead with what we were explaining in the morning session. Yeah, introduction to Hive. Now we'll just study some very important areas about big data analytics and its tools. Introduction to Hive. The Hadoop ecosystem component, Apache Hive, is an open source data warehouse system for querying and analyzing large data sets stored in Hadoop files. Hive do three main functions. First one is data summarization, then we have query, and then we have analysis. Hive use languages called Hive QL, which is very much analogous to SQL, that is Hive query language. Hive query language automatically translates SQL like queries into MapReduce jobs, which will execute on Hadoop. This is an example of your Hadoop cluster. We have a master and we have many slaves. And as we can see that our SQL queries are being converted to our Hive queries. Main parts of Hive are metastores. It stores the metadata, driver, manage the life cycle of a Hive QL statement. Query compiler compiles Hive QL into directed acyclic graphs, that is DAG, and then we have Hive server, that is to provide a thrift interface, and JDBC, that is Java Database Connectivity, and ODBC server. Introduction to Pig. Apache Pig is a high-level language platform for analyzing and querying huge data sets, data stored in HDFS. Pig, as a component of Hadoop ecosystem, uses Pig Latin language. It is very similar to SQL. It loads the data, applies uh, applies the required filters, and dumps the data in the required format. For programs execution, Pig requires Java runtime environment. This is an image that how Pig Latin is used to express the data flows. This image will be explained here. In step number one, we can see that Pig is directly related to our data flows. Environment execution environment leads to our local execution in single Java virtual machine. Pig script is converted into input file present in HDFS using Pig Latin compiler, and UDF present in the local file system is then leading to output file that will be stored in the HDFS. So features of Apache Pig are extensibility. For carrying out special purpose processing, users can create their own function. Optimizing opportunities, Pig allows the system to optimize automatic execution. This allows the user to pay attention to semantics instead of efficiency. Handles all kind of data. Pig analyzes both structured as well as unstructured data, which is a big advantage. Then we move on to our next slide. I think this slide was incomplete. We'll just complete it. Or we completed it. Yeah, we completed this slide. Yeah. Okay. Then we have introduction to NoSQL. The crucial factor about NoSQL is that it can handle huge amount of data and can achieve performance by adding more machines to your clusters and can be implemented on commodity hardware. There are close to 150 NoSQL databases in the market, which will make it hard to choose the right one to be implemented on your system. Why we use NoSQL, why this tool is so important, or why this tool is required in the first place. There are different kinds of data structured, unstructured, and semi-structured, and hence relational DBMS systems are not designed to manage these types of information in an efficient way. NoSQL databases comes in the picture and are capable to manage it. People today are using various kinds of, excuse me, just a second. क्या है? वर्कशॉप किस चीज का? मेरा नाम कौशिक हो. Okay, so uh, people today are using various kinds of algorithms, and if you talk about the code velocity and implementation level, people wish to execute various activities at the same time. NoSQL is a non-relational TMS that does not require a fixed schema. It avoids joins and is easy to scale as compared to our DBMS, which have a specific schema, and we used to have various joins and groups and clauses in our traditional database structure. NoSQL is free from all of that and is very much scalable, which is a advantage of NoSQL. Then we move ahead. NoSQL database is used for distributed data stores with homogeneous data storage needs. NoSQL is used for big data and real-time web applications. For example, organizations like Twitter, Facebook, Google that collect terabytes of user data every single day. And NoSQL database stands for not only SQL or not SQL. Now, key differences: SQL is basically CQL. This is, I think, the full form of SQL. SQL databases are table-based databases, whereas NoSQL databases can be document-based, key value pairs, and graph databases. SQL databases are vertically scalable, while NoSQL databases are horizontally scalable, quite understandably. SQL databases have a predefined schema, whereas NoSQL databases use dynamic schema for unstructured data. SQL requires specified database hardware for better performance, while NoSQL uses commodity hardware. Now, what are the benefits of NoSQL? NoSQL claims various benefits associated with its usage, from managing data to scalability. Its use has increased drastically. Huge amount of data can be managed and then streamed. Different kinds of data, like structured and semi-structured data, can be analyzed, and analytical activities can be performed. Its object-oriented programming is easy to use and flexible. It provides horizontal scaling instead of expensive hardware. If you want to scale vertically, then additional CPUs and RAMs have to be purchased. But here, horizontal scaling can be used with the help of commodity hardware only. It means you don't have to buy additional CPUs and RAMs, which was earlier the case in our relational DBMS. Then we have NoSQL database classes. First one is the document database. It pairs each key with a complex data structure known as document. It can contain many different key value pairs or key array pairs or even nested documents. Key value stores, they are the simplest NoSQL databases. Every single item in the database is stored as an attribute name or key together with uh, along with its value. Then we have graph store. They are used to store information about the networks such as social connections. Graph stores include Neo4j and Hypergraph DB. Then we have wide column stores. Wide column stores like Cassandra and HBase are optimized for query over large data sets and store columns of data together instead of rows. Then we move ahead. Okay, SQL versus NoSQL. There are a lot of databases used today in the industry. Some are SQL databases, some are NoSQL databases. The conventional is SQL database system that uses tabular relational model to present data and their relationship. The NoSQL is the newer one of them that provides a mechanism for storage and retrieval of data rather than of data other than tabular relations model used in the relational databases. Then we have relational SQL or non-relational SQL data structure. While both of these are viable options, still there are certain key differences among them. M- Main are like the type, languages, the scalability, the structure, property followed, and the support. Type. SQL databases are primarily called relational databases or RDBMS, as we know very well, whereas NoSQL databases are primarily called non relational or distributed databases. Language. SQL databases defines and manipulates the data based on structured query language. SQL is one of the more versatile and widely used options available, which makes it a safe choice, especially for great complex queries. Whereas on the other hand, a NoSQL database has dynamic schema for structured data. Data is stored in many ways, which means it can be document oriented, column oriented, graph based, or organized as a key value store. Then we have the scalability. In almost all the situations, SQL databases are vertically scalable. This means that we can increase the load on a single server by increasing things like RAM, CPU, or SSD, that is solid state drive. Then we have our NoSQL are basically horizontally scalable. This means that you handle more traffic by sharing or adding more servers in our NoSQL database. Then we have the structure, means how they are different on the basis of the structure. SQL databases are table based. On the other hand, NoSQL are either key value pairs, document based, graph databases, or wide column stores. Property followed. SQL databases uh, uses ACID properties, that is atomicity, consistency, isolation, and durability, whereas NoSQL database follows the Brewer's CAP algorithm, that is consistency, availability, and partition tolerance. Then we have the support. Great support is available for all SQL databases from their vendors. NOS, NoSQL databases still have to rely on community support, and a few outside experts are available for setting up and deploying your large scale NoSQL deployments. Some examples of NoSQL databases include PostgreSQL, MySQL, Oracle, and Microsoft SQL Server. NoSQL databases example include Redis, RavenDB, Cassandra, MongoDB, Bigtable, HBase, Neo4j, and CouchDB. Then we move forward. This is another, part to compare both of them. SQL databases are, no, we have already studied it. This is already studied. Okay, some parameters are left. Right, schema. SQL databases have a predefined schema, whereas NoSQL databases use dynamic schema for unstructured data. Then we have ability to scale. SQL da- databases are vertically scalable, whereas NoSQL databases are horizontally scalable. Examples are Oracle, Postgres, and MS SQL. Its examples are, as I explained earlier as well. Now, best suited for SQL is an ideal choice for complex query intensive environment, whereas NoSQL is not very much efficient for complex queries. Hierarchical data storage. SQL databases are not suitable for hierarchical data storage. More suitable, and on the other hand, NoSQL databases are more suitable for the hierarchical data store as it supports key value pair method. Then we have comparison on the basis of variations. One type with minor variations, and on the other hand, NoSQL have many different types which include key value stores, document databases, and graph databases. Then we move ahead. That is the development year. SQL was produced in 1970s to deal with the issues with flat file storage, whereas NoSQL was produced in 2000s to overcome the issues and limitations of SQL database. Open source, a, a mix of open source like Postgres and MySQL are commercial like Oracle databases, whereas NoSQL is a completely open source tool. Then we have comparison on the basis of consistency. It should be configured for strong consistency, whereas on the other hand, NoSQL depends on TBMS as some of us strong consistency like MongoDB, whereas others offers only eventual consistency like Cassandra. Then we have the comparison on the basis of usage. RDBMS is the right option for solving acid issues, that is atomicity. See, as I told you earlier as well, I hope that all of you are aware of these acid properties. And as we know that our RDBMS is based entirely on acid properties, whereas our NoSQL is best used for solving data availability problems. Then we have the comparison of SQL and NoSQL on the basis of importance. It should be used when data validity is very much important, and NoSQL is used when it's more important to have fast data than the right information. That is when we need speed over accuracy. In that case, we will use NoSQL, and when we require accuracy, SQL is widely used. Overall, if we compare NoSQL and SQL on the basis of what is the best option, when you need to support complex and dynamic queries, we should use SQL, whereas we should use NoSQL when we need to scale based on changing requirements. Now, what kind of hardware is used? Specialized DB hardware like Oracle Exadata data are used for SQL, whereas for NoSQL, commodity hardware is used. Then we have the comparison based on network. SQL have highly available network, whereas NoSQL has commodity network. Storage, SQL have highly available storage, whereas NoSQL, in case of NoSQL, commodity drive storage, standard HDD and JBOD. Best features SQL uh, cross-platform support means it is platform independent, can be used on various operating systems and any kind of platform. It is secure, which is most important, and free. Whereas if you see the advantages or best features of NoSQL, they are easy to use, high performance, and flexible tool. Top organizations using Hotsuite, Circle CI, and Coach are using SQL, whereas Airbnb, Uber, and Kickstarter are using the concept of NoSQL. Acid versus base model. Acid is basically atomicity, consistency, isolation, and durability is standard for RDBMS, whereas base basically available, soft state, eventually consistent, is a model for many NoSQL systems. So these are the basic points of comparison between the two, and the same thing is shown in this particular image that SQL is basically dependent on ACID properties, whereas NoSQL is dependent on the base properties. Now, just have a brief look at them. ACID is a set of properties that guarantees that are processed reliability in the context of databases. A single logical operation on the data is called transaction. Atomicity atomicity defines transaction as a logical unit of work which must be either completed with all of its data modifications or none of them is performed. Means that is a task should be completely performed or it should not be performed at all. Then we have consistency. At the very end of the transaction, all the data must be left in a consistent state. Then we have isolation. Modifications of data performed by a transaction must be independent of another transaction. Unless this happens, the outcome of the transaction may be erroneous. And the last we have is durability. When the transaction is completed, effects of the modifications performed by the transaction must be permanent in the system. Then we have a look at the base consistency model, which is used in NoSQL for many domains and use cases. Asset transactions are far more pessimistic. That is, they are more worried about the safety of the data than the domain actually requires. Its first aspect is the basic availability. The database appears to work most of the time. Soft state stores don't have to be right consistent, nor do Different replicas have to be mutually consistent all the time. Eventual consistency. Stores exhibit consistency at some later point. For example, lazily at read time. So this particular slide explained the basic points where we can distinguish between SQL and NoSQL. Then we move forward. Some of the features of Hadoop that we have here. Uh, Economic scalability, flexibility, easy to use, data locality, high availability, distributed. Okay, we'll study them one by one. Hadoop cluster is highly scalable. That is, uh, Hadoop cluster is scalable means we can add any number of nodes, that is horizontal scalable, or increase the hardware ca- capacity of nodes, that is vertical scalable. Hadoop provides fault tolerance. Fault tolerance is the most important feature of Hadoop. HDFS in Hadoop 2 uses a replication mechanism to provide fault tolerance. Hadoop provides high availability. This feature of Hadoop ensures the high availability of data even in unfavorable conditions. Due to the fault tolerance feature of Hadoop, if any of the data node goes down, the data is available to the user from various data nodes containing a copy of the same data. Excuse me for a minute, please. Okay. Uh, then we have that Hadoop is very much cost effective. Since the Hadoop cluster consists of nodes of commodity hardware that are inexpensive, thus provides a cost-effective solution for storing and processing big data. Then we have Hadoop is faster in processing. That is, Hadoop stores data in a distributed fashion, which allows data to be processed distributedly on a cluster of nodes. Then we have Hadoop is based on data locality concept. Hadoop is popularly known for its data locality feature, means moving computation logic to the data rather than moving the data to the computation logic. Then we have Hadoop provides feasibility. Unlike the traditional system, Hadoop can process unstructured data, thus provide feasibility to the users to analyze data of any formats and size. Then we have Hadoop is easy to use. Hadoop is easy to use as the clients don't have to worry about distributed computing. The processing is handled by the framework itself. Then we have Hadoop ensures data reliability. In Hadoop, due to the replication of data in the cluster, data is stored reliably on the cluster mechanics despite of machine failures. So these are some of the features of Hadoop that we had. Then we move ahead. Some of the latest versions of Hadoop. Hadoop is an open source framework overseen by Apache Software Foundation, which is written in Java for storing and processing of huge data sets with a cluster of commodity hardware. Hadoop comes as the solution to the problem of big data, that is, storing and processing the big data with some extra capabilities. There are mainly two components of Hadoop, which are Hadoop distributed file system, that is HDFS, and yet another resource negotiator, that is Yarn. We studied both of them in the morning. Then we have Hadoop versions. There are two basic versions of Hadoop, that is Hadoop 1x, that is version 1, and Hadoop 2, that is version 2. Hadoop was started with Doug. Uh, it was started with Doug Cutting and Mike Cafarella in year 2002 when they both started to work on Apache Nudge project. In 2003, they came across a paper that specified the architecture of Google's distributed file system called GFS or Google File System, which was published by Google for storing the large data sets. In 2004, Google published one more paper on the technique MapReduce, which was the solution of processing those large data sets. In 2005, Cutting found that Nudge is limited to only 20 to 40 nodes. So in 2006, Doug joined Yahoo along with Nudge project, open source, reliable, scalable computing framework. In 2007, Yahoo successfully tested Hadoop on a 1000 node cluster and start using it. In 2009, Hadoop was successfully tested to sort a petabyte of data in less than 17 hours. Petabyte is a huge amount of information for handling billions of searches and indexing millions of web pages. In December 2011, Apache Software Foundation released the first version, that is Hadoop version 1.0. Later in August 2013, version 2.0.6 was available, and presently we have Apache Hadoop version 3 and even more advanced than this particular version. Uh, this basically shows exactly the same thing that I just explained to you. That is how Hadoop was evolved and the process of evolution of Hadoop. Now, some of the features here, Hadoop 1x, below are the components of Hadoop 1x. The Hadoop common module is a jar file which acts as the base API on top of which all the other components work. Version 1 being the first one to come in existence is rock solid and has got no new updates. It has a limitation on the scaling nodes with just a maximum of 4,000 nodes for each cluster. The functionality is limited utilizing the slot concept. That is, the slots are capable of running a map task or a reduced task. The next component of the Hadoop distributed file system is known as HDFS. It has distributed storage system, it has large data, and it has a block size of 64 megabytes for supporting the architecture. uh, Hadoop 1 uses MapReduce data processing model. It is not capable of supporting other than non-MR, that is non-MapReduce tools. Hadoop version 2 was released to provide improvements over the lags which the users faced in Hadoop version 1. HDFS Federation, which was improved to provide for horizontal scalability of the name node. The Hadoop stat has been increased to include the stacks like Hive and Pig. Yarn stats stands for yet another resource negotiator, and terabyte to make it available for the HDFS. The update basically focused to provide for major functionalities that are providing for your application and providing for a global resource manager. Then we have version 3. It was released on 21st of October 2019. This update enables Hadoop to be utilized as a platform to serve big chunk of data analytics functions and utilizes to be performed over event processing alongside using real-time operations and provides better output. It has now improved feature work on the container concept, which enables head to perform g- generic, which were earlier not possible with Hadoop version 1. Latest version addresses issues of non-functionality of data nodes for multi-tenancy and limitation. Hadoop app great to store, process, and assess the great solution. Hadoop and the improved version increase the scope of application and improves the dimensions and flexibility of using Hadoop. So this was about evolution of Hadoop, how various versions of Hadoop were evolved. Then we move on to our next slide. That is Hadoop distributions. Okay. Hadoop is an open source. It catch all the technology solution with incredible scalability, low cost storage systems, fast big data analytics, economical server costs. Hadoop vendor distributions overcome the drawbacks and issues with the open source edition of Hadoop. These distributions have added functionalities that focus on Hadoop vendors, that is, technical guidance, assistance that makes it easy for the customers, adopt Hadoop for enterprise level tasks, mission critical applications. Then we have Hadoop vendors. These are commercial solutions which are more stable, patches and fixes deployed immediately. Uh, they are basically distributions with various other add-ons tools which help customers customize the Hadoop application, address their specific tasks. Hadoop distributions. This is the list of top Hadoop vendors. Key role in big data market. Amazon Elastic MapReduce, Cloudera CDH Hadoop distribution, Hortonworks data platform, MapR Hadoop distribution, IBM Open Platform, Microsoft Azure's HD Insight cloud-based Hadoop distribution, Pivotal Big Data Suite, Datamere Professional, DataStax Enterprise Analytics, Dell Cloudera Apache Hadoop solution. These are some of the Hadoop distributions. Then we move forward. Amazon Hadoop vendor, innovative Hadoop distributions in the open data platform. AWS Elastic MapReduce renders. They are easy to use. They are well organized. Data analytics platform built on the powerful HDFS architecture. Focus on map reduce queries. Uses high scale and secure infrastructure platform to its users. A AWS EMR handles important big data. They use it uses like web indexing, scientific simulation, log analytics, bioinformatics, machine learning, financial analytics, and data warehousing. DynamoDB is another major NoSQL database offered by AWS Hadoop vendor. Redshift is a completely managed petabyte scale data analytics solution that is cost effective in big data analysis. Hortonworks Hadoop distribution. Hortonworks is an open source Hadoop distribution in IT market. The main goal of Hortonworks is to drive all its innovations through the Hadoop Open Data Platform, build an easy ecosystem for partners that speeds up the process of Hadoop adoption amongst enterprises. Then we have Apache Ambari, example of Hadoop cluster management console developed by Hortonworks, Hadoop vendor for provision, managing and monitoring Hadoop clusters. The Hortonworks Hadoop vendor have 60 new customers every quarter, like Samsung, Spotify, Bloomberg, and eBay. Hortonworks has generative storing engineering partnership with Red Hat, Microsoft, SAP, and Teradata. Cloudera Hadoop distribution. Cloudera Hadoop vendor ranks top in the big data vendors list for making Hadoop a reliable platform for business use since 2008. It was founded by a group of engineers from Yahoo, Google, and Facebook. Enterprise ready solutions of Hadoop with additional customer support and training. Cloudera, its long-term success to corporate partners like Oracle, IBM, HP, NetM, and MongoDB that have been consistently pushing its services. Cloudera's approaches to innovation is to be loyal to core Hadoop, innovate quickly and aggressively to meet customers' demands, differentiate its solutions from those of other commercial Hadoop vendors. Then we have MapR Hadoop distribution. MapR has made considerable investments to worldwide adoption of Hadoop, which include enterprise-grade reliability, data protection, integrating Hadoop into existing environments with ease, and infrastructure to render support for real-time operations. MapR is all set to announce its technical innovations, increase revenue, mitigate risks, and reduce costs. Now, here we show MapR Hadoop distributions. This is exactly the same thing that I have just already explained you in the slides. MapR Hadoop distribution, high availability. Okay, this we'll just explain this particular thing. It is useful. Now, this basically shows the performance and scalability comparison between Hortonworks, Cloudera, and MapR. First one is the data ingest. Hortonworks uses batch, Cloudera uses batch, and MapR uses batch and streaming rights. Metadata architecture. Hortonworks have centralized architecture. Cloudera has centralized architecture, whereas MapR has distributed architecture. Edge-based performance. Hortonworks has latency spikes. Cloudera also has latency spikes, whereas MapR has consistent low amount of latency, which is an advantage of MapR. Then we have NoSQL applications, that is comparison based on NoSQL applications. Hortonworks mainly batch applications. Cloudera again mainly batch applications, whereas MapR batch and online and real-time applications. Then we have a comparison on the basis of high availability. Hortonworks have single failure recovery. Cloudra has again single failure recovery, whereas MapR have self healing across multiple failures. MapReduce HA both Hortonwork and Cloudra restarts the jobs, whereas our MapR continues without restarting the job. Then we have comparison on the basis of upgrading, planned downtime, rolling upgrades in MapR. Then we have the comparison on the basis of replication. Both Hortonwork and Cloudra replicates data, whereas MapR replicates data plus metadata data. Then we have comparison based on the snapshots, consistent only for closed files, that is for both Cloudra and Hortonworks. And for MapR, we have point in time consistency for all files and tables. Then we have disaster recovery. Hortonwork has no disaster recovery option. In Cloudra, we have file copy scheduling, which is important, and in Mapper we have mirroring. That is, entire data is being mirrored, and in that case, we can have a disaster recovery option in Mapper as well. Then we have comparison on the basis of management tools. Hortonworks and Cloudra uses Ambari and Cloudra Manager respectively, whereas Mapper uses Mapper Control System. Then we have comparison on the basis of volume support. Hortonwork and Cloudra do not have any kind of volume support, whereas Mapper has its own volume support. And then we have comparison on the basis of alarms, alerts, and heat maps. All of them have this ability. Then we have integration with rest of the APIs. All of them have the ability for integrating with the rest of the APIs. Then we have data and placement control. Both Cloudra and Hortonworks do not have this ability, whereas Mapper do possess this particular ability. Then we have the comparison on the basis of file system access. Hortonwork uses HDFS and read-only NFS. Cloudra as well, the same, that is HDFS and read-only NFS, whereas Mapper uses HDFS, read and write NFS. Then we have comparison on the basis of file input output. Hortonwork uses append only, same as Cloudra, whereas Mapper uses read and write. Then we have comparison on the basis of security parameters. All of them are secure. Then we have wire level authentication for both Cloudra and Hortonwork. We have Kerbos, whereas for Mapper we have Kerbos as well as native. Uh, then we have our Hadoop distributions, that is IBM, Infosphere, Big Insight Hadoop distribution. IBM Infosphere Big Insight is an industry standard IBM Hadoop distribution that combines Hadoop with enterprise grade characteristics. IBM provides big sheets and big insights as a service via its smart clouds, enterprise infrastructure. IBM Big Insight innovation, customers can get to market at a rapid pace with their applications and incorporate advanced big data analytics. Then we have Microsoft Azure's HD Insight cloud-based Hadoop distribution. Microsoft is an IT organization, not only knows, just a second. Yeah, Microsoft is an IT organization not only known for embracing open source software solutions, but it has made efforts to run its this open data platform software on the Windows. Hadoop as a service offering by Microsoft's big data solution is the best leveraged through its public cloud product. Windows use SD Insight particularly developed to execute on Azure. This was the comparison between various features of Hadoop we have. Then we move on to our next slide. Okay, I think we have already studied this concept, difference between Hadoop and SQL. Let's see if you can find anything interesting from this. Uh, Okay, this is good. Uh, Framework of Hadoop versus SQL. Earlier we studied, SQL versus NoSQL. Here we'll study Hadoop versus SQL. The Hadoop ecosystem have two primary components. That is the HDFS and MapReduce, whereas SQL Server, on the other hand, is an relational database management system, and it is one of the world's most powerful data platform used by a large number of commercial and in-house products to query, manipulate, and visualize a variety of data sources. Data types. Hadoop is designed to work with any data type. There is no restriction at all. For example, structured data, semi-structured data, or unstructured data, making it very flexible to work with when it comes to big data processing. Whereas on the other hand, SQL is a programming language specifically created for managing and querying data in relational database management system, that is RDBMS. Then we have comparison on the basis of processing. The HDFS is a distributed file system designed to support batch processing of data, meaning data is collected in batches and each batch is sent for processing. The batch can be anything from 1 day to 1 minute. Since it's designed for batch processing, it does not have the concept of random reads or writes. Whereas on the other hand, SQL Server as a general purpose database platform supports real-time data processing, data is streamed. Then we have performance of Hadoop and SQL. The architecture of Hadoop sometimes leads to an impedance mismatch between data storage and data access. It has fewer restrictions or validations on the data that it stores, and it does not have the same end user capabilities and ecosystem that SQL has developed. SQL Server handles enforcing data quality and consistency much better than Hadoop, which enables it to leverage the ecosystem of SQL-based data analysis and data visualization tools. However, SQL has some drawbacks, which includes scalability to handle massive amounts of data and support for storing loosely formatting data. Uh, Hadoop is an open source distributed processing software framework for storing and processing massive influx of data across clusters. On the other hand, SQL has been the ubiquitous tool to access, manipulate, and store data in the database. Hadoop is designed to work with any uh, data type, structured, semi-structured, or unstructured, whereas on the other hand, NoSQL can only process structured data and cannot be used for unstructured data. Hadoop supports batch processing of data, whereas SQL supports real time processing of data. Hadoop does not have the same end user capabilities and ecosystem that SQL has. SQL handles enforcing data quality and consistency much better than Hadoop. Hadoop is ideal for processing and storing massive amounts of data, whereas on the other hand, SQL is best for processing less amounts of data and has problems dealing with large volumes of da- data sets. Uh, then we move on. Okay, here we have uh, business drivers for big data. Big data emerged in the last decade from a combination of business needs and technology innovations. A number of companies that have big data at the core of their strategy have become very successful at the beginning of 21st century. Famous examples include Apple, Amazon, uh, and Facebook. A large number of business drivers are at the core of success and explain why big data has quickly risen to become one of the most covered topics in the industry. Six main business drivers can be identified as following: the digitization of society, then we have plummeting of technology costs, then we have increased knowledge about data science, social media applications, the upcoming Internet of Things, the digitization of society. We'll explain it now. Just excuse me for a minute. Just a second. Okay, thank you. So we'll just explain this particular slide now. Big data is largely consumer driven and consumer oriented. Most of the data in the world is produced by consumers who are nowadays always on. Most people now spend 4 to 6 hours per day consuming and generating data through a variety of equipments and social applications. With every click, swipe, or a message, new data is created in the database somewhere around the world. Because everyone now has a smartphone in their pockets, the data creation sums to incomprehensible amounts. Some studies estimate that 60% of data was generated within last 10 years, which is a good indication of the rate which with which society has digitized. The plummeting of technology costs. Technology related to collecting and processing massive quantities of diverse and high variety of data has become increasingly more affordable. The cost of data storage and processors keep on declining, making it possible for small businesses and individuals to become involved with big data. Then we have connectivity through cloud computing environments where data is remotely stored in a distributed storage systems have made it possible to scale up or scale down IT infrastructure and facilitate a pay as you go model. This means that organizations that want to process massive quantities of data and thus have large storage and processing requirements do not have to invest in large quantities of IT infrastructure. Instead, they can license the storage and processing capacity they need and only pay for the amounts they actually used. As a result, most of big data solutions leverage the possibilities of cloud computing to deliver their solutions to enterprises. Then we have increased knowledge about data science in the last decade. The term data science and data scientists have become tremendously popular. The demand for data scientists and similar kind of jobs has increased tremendously, and many people have actively become engaged in the domain for data science. As a result, the knowledge and education about d- data science has greatly professionalized, and more information becomes available every day. While statistics and data analysis mostly remained an academic field previously, it is quickly becoming a popular subject among students and the working population. Then we have social media applications. Everyone understands the impact that social media plays on our daily lives. However, in the study of big data, social media plays a role of paramount importance, not only because of the sheer volume of data that is produced every day through platforms like Twitter, Facebook, LinkedIn, and Instagram, but also because social media provides nearly real time data about human behavior. Social media data provides insights into the behaviors, preferences, and opinions of the public on a scale that has ne- never been known before. Due to this, it is immensely valuable to anyone who is able to derive meaning from these large quantities of data. Social media data can be used to identify customer preferences for product development, target new customers for future purchases, or even target potential voters in elections. Social media data might even be considered one of the most important business drivers in big data. Upcoming Internet of Things. The Internet of Things is the network of physical devices, vehicles, home appliances, and other items embedded with electronics, software, sensors, actuators, and network connectivity, which enables these objects to connect and exchange data. It is increasingly gaining popularity as consumer goods providers start including smart sensors in household appliances, whereas the average household in 2010 had around 10 devices that connected to the internet. The number is expected to rise by 50 per thousand by 2020. Examples of these devices includes thermostats, smoke detectors, televisions, audio systems, and even smart refrigerators. This is an example of Internet of Things, which I explained in the morning as well, that these are closely r- related areas, that is Internet of Things and big data analytics. As we can see that, from agriculture, travel, energy usage, everyday things, building management, security equipments, smart homes and cities, embedded mobile, and we get data from every facet of the society, and all that data combines forms a part of big data. So IoT and big data analytics, as I say again, are very much closely related to each other. Then we move on to our next slide. Okay, responsibilities of data scientists. We have now data scientists work closely with business stakeholders to understand their goals and determine how data can be used to achieve these goals. They design data modeling processes to create algorithms and predictive models to extract the data the business needs, then help analyze the data and share insight with the peers. Responsibilities of data scientists. Here are some of the responsibilities that a particular data scientist has working on big data tools. Ask the right questions to begin the discovery process. Acquire data, process and clean the data, integrate and store data, initial data investigation and exploratory data analysis, choose one or more potential models and algorithms, apply data science methods and techniques such as machine learning, statistical modeling, and artificial intelligence, measure and improve the results, present final output to the stakeholders, make adjustments based on the feedback, repeat the process to solve a new problem. These are some of the major responsibilities of a particular data scientist. The most common careers in data science include the following roles. First one is the data scientist, as I explained you earlier as well, that is to design data modeling processes to create algorithms and predictive models to perform custom analysis. Then we have data analytics, that is to manipulate large data sets and use them to identify trends and reach meaningful conclusions to inform strategic business decisions. Then we have our data engineers, that is to clean, aggregate, and organize data from disparate sources and transfer it to data warehouses. Then we have our business intelligence specialist. In the morning session, we just studied the whole concept about BI, that is business intelligence. Now, business intelligence specialist, that is to identify trends in the data sets. Then we have data architects, that is to design, create, and manage an organization's data architecture. Uh, Data scientists use the following core skills in their everyday work. First, we have statistical analysis, that is to identify patterns in data. This includes having a keen sense of pattern detection and anomaly de- detection. Then we have machine learning to implement algorithms and statistical models to enable a computer to automatically learn from the data. Then we have computer science, apply the principle of artificial intelligence, database systems, human computer interaction, that is HCI, numerical analysis, and software engineering. Then we have programming, which is very important. Write computer programs and analyze large data sets to uncover answers to complex problems. Data scientists need to be comfortable writing code, working in variety of languages like Java, R, Python, and SQL. Then we have data storytelling, that is to communicate actionable insights using data, often for non technical audience as well. Then we have scientists play a key role in helping organizations make sound decisions. As such, they need soft skills in the following areas. First one is the business intuition. It is to connect with the stakeholders to gain full understanding of the problem they are looking to solve. Then we have analytical thinking, that is to find analytical solutions to abstract business issues. Then we have critical thinking, that is to apply objective analysis of facts before coming to a conclusion. Then we have in inquisitiveness, that is to look beyond what's on the surface to discover patterns and solutions within the data. Then we have interpersonal skills, that is to communicate across a t- diverse audience across all levels in an organization. So these are, some of the skills and responsibility of data scientists that are working on big data analytics. Then we come to our last slide. Some of the real-time applications of big data in healthcare. Traditionally, a huge amount of data generated by healthcare industry was stored as hard copy. This data has the capability to support a wide range of healthcare and medical functions. The digitization of such data is called big data. The entirety of data that is related to patient healthcare and well-being makes up big data. Big data applications in healthcare, a wide diversity of big data, and the pace at which it is managed makes it overwhelming. It includes clinical data from COP and clinical decision support systems, that is, physicians, written notes and prescriptions, medical imaging, laboratory, pharmacy, insurance, and other administrative data, patient data in electronic patient records, that is EPRs, machine generated sensor data, such as from monitoring vital signs. Then we have social media posts, including Twitter feeds, so called tweets, blogs, status updates on Facebook and other platforms, and web pages, and less patient specific information, including emergency care data, news feeds, and articles in medical journals. Then we have healthcare data solutions. With help of big data, the vast amount of data can be stored systematically. Now, doctors and other healthcare practitioners can make informed decisions as they have access to a wide range of data. Of course, the data generated will grow by leaps and bounds, and newer systems will be able to process it quickly and in a cost effective manner. Now, big data to fight cancer. Cancer is rapidly creeping people across the world. Big data can help to fight cancer more effectively. Healthcare providers will have enhanced ability to detect and diagnose diseases in their early stages, assigning more effectual therapies based on a patient's genetic makeup, and regulate drug doses to minimize side effects and improve effectiveness. It will also provide great support for parallelization and help in mapping the 3 billion DNA based pairs. Then we have monitoring patient vitals. The application of big data makes it easier for hospital staff to work more efficiently. Sensors are used besides patient beds to continuously monitor blood pressure, heartbeat, and respiratory rates. Any change in pattern is quickly alerted to doctors and healthcare administrators. Smoother hospital administration. Big data is also useful in this domain. Healthcare administration becomes more smoother with the help of big data. It helps to reduce the cost of care measurement, provide the best clinical support, and manages the population at risk patients. It also helps medical experts to analyze data from diverse sources. It helps healthcare providers conclude the deviations among patients and the effects treatments have on their health. Healthcare intelligence, also important thing. Big data can be used for healthcare intelligence application. This will help hospitals, payers, and healthcare agencies augment their competitive advantages by developing smart business solutions. Fraud prevention and detection. Big data helps to prevent a wide range of errors on the side of health administrators in the form of wrong dosage, wrong medicines, and other human errors. It will also be particularly useful to insurance companies. They can prevent a wide range of fraud claims of insurance. Then we have big data applications in medicines. Most companies make conscious and deliberate decision to embrace digitization and the information revolution. The role of big data in medicine is one where we can build better health profiles and better predictive models around individual patients so that we can better diagnose and treat the disease. One of the main limitations with medicine today and in the pharmaceutical industry is our understanding of biology of the disease. Big data comes into play around aggregating more and more information around multiple scales for what constitutes a disease, from the DNA, proteins, and metabolites to cells, tissues, organs, organisms, and ecosystems. Big data applications in advertising. Successful digital advertising depends upon the ability to collect, integrate, and analyze data from both internal and external sources. The challenge lies in the fact that 80% of that data is unstructured or chaotic. Then we have big data applications in advertisement continued. The digital advertising industry is evolving like never before. The ability to capture and analyze massive amounts of structured and unstructured data is helping digital advertisers to discover new relationships, spot emerging trends and patterns, and gain actionable insights that lead to competitive advantage. Then we have more personalized and targeted ads. Big data allows digital advertisers to better target users with more personalized ads that they most likely want to see. Google and Facebook, the dominant players in the digital advertising, have gotten very fine, very good at creating and proceeding and producing more appealing ads in non-intrusive ways. Ads featuring products and services we might actually want and used to better our lives. And these more personalized and targeted ads are all based on massive amounts of personalized information and da- data that we constantly provide about what we are doing, saying, liking, or sharing. So this was about use of big data and its application in healthcare industries. So here I conclude all my slides and PPTs and the applications, including big data analytics and the research contents as well. So